Welcome. In this video, we are beginning our discussion on Unit 3 with Activity 1. So let's begin. A museum charges $6 for admission. On an average weekend, 200 people visit the museum. Now, the manager of this museum's business operations would like to increase the price of admissions, but in researching this option, she has found that for every dollar increase in price, she will lose 15 customers. The manager knows she can determine the weekend revenue by multiplying the number of visitors by the ticket price, so she writes an equation to model this revenue. And you can see this model below visually, although I have it partially cut off in the video. We'll get there. Anyways, she simplifies the equation resulting in this function, and we're really not going to go into how to get this function, but this function is the algebraic model, and here we have a graph of this algebraic model. And this models the revenue for this weekend, for this museum's weekend visitors, where X is the number of dollars the price would be increased. And again, this is our weekend revenue. Okay, let's look at problem 1. Problem 1, describe the shape of the graph. How is it different than the shape of linear exponential functions? And now I'm not going to write anything down. I'm going to go over a few key things on this shape, and please write down your own notes in this section here. So if you recall, linear graphs look like this, or they can go downhill or be flat. This is what linear models will look like in general. This one does not look like a linear model since it is not a straight line. Notice we can go up and then it curves downward. Exponential models look somewhat like this. So they just curve and continue going upward, and they don't come back down. Whereas this one starts low, goes up, turns around, and goes low. We could also have a model that looked like this. What you're seeing in front of you is the graph of a parabola. We also call these quadratic functions. Number 2. What does the graph tell you about what happens as the price is raised? Well, here at 0, this represents $6 admission cost. And if we raise the price $1, it looks like the revenue will go up. And the revenue keeps going up until you get to about here. And that's somewhere between an increase in price of $3 and $4. That would take the total ticket price to between, this is 6 plus 3, so this would be $9, and this is 10. So somewhere between $9 and $10 admissions, we level off, and then the revenue starts to decrease. And again, I'm not writing anything down here, so please take some notes. Number 3. Use the given information to find the current weekend revenue. And I can sketch that out right on the graph because currently the price has not been raised. So this represents a ticket price of $6 right here. And the revenue with a $6 ticket price is up here at $1,200. So per the graph, weekend revenue, and I'm writing this in the wrong spot, so let me move it, is $1,200. Now, how can we verify this using the equation? So let's use the formula for the model. And that formula is negative 15x squared plus 110x plus 1,200. And remember, what is x in this case? X is 0. So we have negative 15 times 0 squared plus 110 times 0 plus 1,200. And you'll notice that this is 0, this is 0. So we end up with just 1,200. So we verified the current revenue using both the graph and the algebraic model. Now, I still want to see the graph, so I'm going to show the graph at the beginning and then hide it so we can write in our answer. So for number 4, let's mark the X-intercept points on the graph. So let's start there. I'm going to mark them in blue. Here's one of them, and here's another one. Let's record the x-intercepts below and explain what each of these points mean in this situation. So first I have x equals -6, and this other one is kind of an estimate. I'm going to estimate that it's about 13.3. Let me make this neater. This is approximately 13.3. That's my guess. Now I'm going to hide the graph so we can actually discuss what these mean. So what does each x-intercept mean in this situation? So for x equals -$6, this represents decreasing. The current ticket price from $6 to $0. That's because 6 minus 6 equals 0. And decreasing the price $6 so that admission is free projects a revenue, of $0. So per this model, the revenue would be $0. So no money for the park if they offer free admission. Okay, let's look at 13.3. So this represents increasing the current ticket price an additional $13.30 to about $19.30. Now, again, if we increase, or if this person that manages the weekend admission costs at this park increases the ticket price by $13.30 a ticket for a total ticket price of $19.30, this model projects that there will be 0 revenue.